Today we're doing section 1.3, day 3, and we are going to be graphing piecewise functions. Again, this should be a relative review from what we did last year in Algebra 2. So notice here's your two pieces. We have 3x plus 1, and that's if x is less than 1. So we're going to write that over here on this t-chart. When x is less than 1, we use 3x plus 1. When x is greater than or equal to 1, we're going to use negative x minus 3. So then it's important you pick appropriate x values for each t-chart respectively. So over here, x values that would be true would be 0, negative 1, negative 2. However, we still need to plug in 1 so that way I know where my placeholder needs to go of an open dot, because all the values between 0 and 1 are less than 1. Over on the other t-chart, 1, 2, 3, 4 would be sufficient amount of points for that right side one. Now we just plug in the values. So going over to the left one, when I plug in 0, I get 1. When I plug in negative 1, we get negative 2. When I plug in negative 2, I'll get negative 6 plus 1, which is negative 5. And if I plug in 1, I get 4. And this is going to be an open dot if you want to make a note of that. My other values, when I plug in 1, I get negative 4. When I plug in 2, I get negative 5. When I plug in 3, I get negative 6. When I get 4, I get negative 7. So before we can do the domain and range, it's in our best interest to plot these two pieces. So we're going to plot our points. So let's start with the left-hand side. So 1, negative 4, 2, 3, 4 is my open dot. I have 0, 1. I have negative 1, negative 2, and negative 2, negative 5. And I'm going to connect this going to the left because that's how my x values will continue on the t-chart. They'll keep getting smaller and smaller. The other piece, my point is 1, negative 4. And let's say closed dot. Then I have 2, negative 5, 3, negative 6, 4, negative 7, and so on. So this piece is going to keep growing to the right because my x values are going to continue to get larger. So looking at this picture, my domain is going to be from negative infinity to infinity, because when I slide those two x values together, 1 is hit somewhere, and that's all that matters. The range is negative infinity to positive infinity as well, because where this piece stops, the other one would pick up. So no y values are missing. And when I said to positive infinity, I was totally just kidding. I'm just checking to make sure you're awake. So my y values actually only go up to 1, 2, 3, 4, but it's not included, so we have to put a parenthesis. All right, so let's go through one more together. So we're going to set up our chart. So for the left chart, we'll say x is less than 0. And when x is less than 0, we use x squared minus 2. For the other chart, when x is greater than 0, we use the y value of 3. So on both t-charts respectively, we need to use the value of 0 because I need to know where the open dots go on both charts. However, this left one, I can use negative 1, negative 2, negative 3. The right chart, I would use 1, 2, 3. So when I evaluate this, negative 1 squared is 1. 1 minus 2 is negative 1. A negative 2 squared is 4. 4 minus 2 is 2. Negative 3 squared would be 9. 9 minus 2 would be 7. And for our open dot, when I plug in 0, I get the y value of negative 2. On my other chart, when I plug in 1, I get 3. I get 3, I get 3, and I get 3. There's nowhere to plug in anything. Therefore, it's a constant piece at the y value of 3. So we plot our points. So let's do the left table first. So 0, negative 2 is my open dot. Then I have a negative 1, negative 1. I have a negative 2, 2. And I have a negative 3, 7. So 2, 3, 4, 5, 6, 7. And this one's going to grow to the left. So notice it's half of a parabola. You should have known that based on the fact that it is squared. My other piece is at 0, 3. 1, 2, 3. Open dot again. And the dots are going to be all closed going to my right, so I can know it's just going to travel this way and it's going to be a solid line. So this time there will be a union in my domain, so my domain will go from negative infinity, but it has to stop at the x value of 0. I have to union it and then continue from 0 to infinity. So because 0 is not included anywhere, I have to restrict it from my domain. My range, the lowest y value I have is negative 2, not included, and it's going to continue up to infinity. So the reason I don't have to stop at that positive value of 3 is there's no restriction. 3 is hit the end, so I don't have to restrict that value. So we're definitely going to practice lots of these tomorrow. In Algebra 2, you're probably stuck to mostly linear piecewise functions, so we're going to focus more on having quadratics within our piecewise functions.